So we're doing this a little differently. First, we're using the new sharing slides, but the second thing is we're gonna have two presenters at today's thing. So we are going to present HPC help and security. I'm going to start with the public service announcement about getting help and support at the HPC systems. And then I'm going to pass the baton over to our lead security guy, Scott Sakai, to share some thoughts on HPC security. So today's presentation is brought to you by Complex. For those of you who have not been to one of our sessions before, Complex is an NSF-supported training program. As over time, as the systems and the folks who are using the systems have changed, so have the needs of the training that's being provided to them. So this is specifically for people who are more non-programmers. So while there's going to be a little bit of programming and technical stuff involved, it's a little more high level. You're not going to necessarily get into the MPI training and the debugging. So the agenda for today, specifically for the help, is to start with why we decide that it was really important that we provide a little bit of a help discussion on this, or why anyone needs to have a presentation on help, because basically all the presentations we have are to help you move forward. But this is specifically just when users run into problems, they want the quickest turnaround, how to make sure they get that quick turnaround on getting back onto the system. That very gently leads us into a little bit of discussion on the HPC ecosystem. And then a reminder of all the resources that are out there to help you. A lot of times the help desk is the first place you jump to, but it's not always the quickest resource. Then we'll specifically talk about the help desk. And since this is going to be a really kind of short, less than 15 minutes discussion, I have a lot of slides that if you download the slides from our GitHub page, there's slides that present all kind of the most common issues we find at the help desk and solutions. And I will update it again kind of over the time. I did change some of the slides right before we came in here. So if you update it maybe half an hour after this, then you'll have the latest references I can provide you. So the motivation, as the systems have changed over time, the users have changed over time, the applications that are being used on the systems have changed over time. But overall, the questions that were being asked have not changed over time, and the overall goal of users on the systems hasn't changed over time. So the overall goal is to get your science done. But inevitably, you're going to run into an issue at some point, and the goal is to get back moving as quickly as possible. A lot of people don't really care how quick their job runs, but they really don't want to spend much time talking to the help desk trying to figure out why it's not running. We also want to make sure that everyone's aware of what the system is, so to make sure that they're not hindering other people on the system, so kind of promoting good citizenship. And then finally, when they do get to the point that they do need the help desk, to make sure that your turnaround time with the help desk is used as efficiently as possible. So the HPC system is a shared resource. So I'm going to say you are not alone. And if you could have subtitles down below, it would say like dark and ominous. And while that's not always a bad thing, it can be. So let's talk first about what all is shared. So the first thing is the login nodes are shared, the file system is shared, the compute nodes are shared, and then all the resources that make sure that the system running is shared. So all your system administrators, your security team, your networking team, and your user support team. So just on average, if you think about these HPC systems, they can have thousands of users on it, but the support team keeping the thing running is probably less than 10 full-time employees. So the users far outnumber the support team. And while I really enjoyed the mosh pit when I was younger, the chaos of it was fun and lively. It is not exciting when it's on your login nodes. So if any of you have a login to any of the HPC clusters, at any time you can type a who command, and you can see how many people are on that system. So on the login nodes, if you type the who command at any time, you're going to see lots of users on there. I typed it on Expanse sometime last week, and it was about 200 users. And there are some people who are logged in more than once. So you can first, if they're logged in more than once, login nodes are specifically used for, you know, doing small editing tasks, checking out files, maybe copying small files in and out, but they're not supposed to be used for anything like data intensive. So if people are logged in multiple times, it always makes you wonder why they need multiple logins. So you're sharing this system with all these folks. And it can seem like the wild, wild west. The other thing to consider is the file systems and the compute nodes. So while the login nodes are direct individual users who are logging into them, the file system compute nodes, you're not only contending with the people who logged in directly, but you're also contending with all the people who come in through gateways. So gateways are kind of an individual user comes in, but in the background, they can have thousands of users on them. It ranges from 1 user to about 2,000. So at any given time, you can have 2,000 of your not closest friends sharing the file systems and compute nodes. So making sure that what they're doing on there, again, their intentions of what they need to do on there and their knowledge of what compute systems can handle is vastly different. So understanding what's going on is really important. The other thing to keep in mind is that the system policies, a lot of time people ask us why these system policies are in place. And it's a direct response to how people are using the systems. So some people come in and they launch thousands of jobs and they can dominate the queue, not letting anyone else come in. So we have policies in place to ensure that individual users and individual groups cannot dominate the systems. On the other hand, you are not alone. So again, in the subtitles, this should be a warm, fuzzy feeling. There are lots of people out there who can support you. So let's talk a little bit about who is out there to support you. There's always the help desk, but again, help desk maybe should be the last resource because they might not be the quickest response. There's always going to be tickets that no one else can help you with but the help desk. So if the system is down or you're having problems logging in, yes, only the help desk can ask you. But for a lot of the other problems that we get, and I'll show you a slide on what kind of the most common questions are, there's other support out there that might be quicker. So one of the great places to go to is the web for applications questions or just general HPC questions. There's lots of community forums. The community forums for applications are really strong. They have meetups, they have blogs, all sorts of stuff. Also, Git repositories are a good place to go. I also want to reinforce the idea that you should always check out the user guide. The user guide can have, so you should check out the user guide for the policies. There's some really important policies that if you get onto the system, you can be devastated when you haven't checked them out. Purge policies and backup policies. The HPC support desk is fantastic, but there are some things they cannot do. So knowing when stuff is gone is really important. So I strongly encourage anyone, whenever they get onto a new system, check out the user guide first. Another great resource is your project or colleagues, the people sitting next to you in your lab. They will have the most knowledge about the research you're doing, the science behind the research you're doing, and potentially the applications you are using. But both with projects, colleagues, and the web, you should be really careful to make sure your source and if they are really an expert in what they're talking about. If it's performance on an HPC system, again, the help desk is going to be the person you want to talk to because your colleague who doesn't have a strong background in computer science and specifically parallel computing might not be the best person to tell you how to best abuse a HPC or parallel file system or write parallel code. And finally, and then there's also software tools. Software tools can help you understand what exactly the system is doing. It can help you debug programs, and it can help you kind of performance tune. You can so you can have debuggers. performance analysis, performance analysis, excuse me. And then again, there's always the help desk. So to focus a little, before we actually get to the help desk, let's talk about some general tips. I am in admiration of my fellow support team within the entire Access community. Unfortunately, they are not magicians and they're not clairvoyant. So when things are gone, they cannot bring them back, and they don't know what happened necessarily in some cases if it was work that you did. So, and something really important to remember is that the HPC systems are definitely dominated by Murphy's Law, saying that anything that can go wrong will go wrong at the most inopportune moment. So the general tips are: don't leave HPC tasks last minute. Pay attention to the notifications that you get via email or in the messages of the day. If our system's going down for a maintenance, there's nothing the support team can do to bring up that system. If the file system crashes in an evening, we have to wait until it's fixed and it's back up. There's nothing we can do to help you. Another thing is back up your data. There are purge policies on the system, and there are also data retention policies on the system. On the Scratch and or on the Lustre file system, for example, at SDSC, there we don't back up your data. We do take snapshots of the persistent file storage so that in case of a catastrophe, we can bring something back up, but most likely your thesis that was written 3 days ago is gone. There's nothing we can do for you. The other thing is use version control. Any changes you make, if it changes your data, it's going to be very hard, or it can be done, but it's harder if we have to go back and try and undo or figure out what you've done in the past. So, help desk. It's really important to give us a clear description, or when you come to the help desk, I like to think of it kind of as the Goldilocks syndrome. So we need to have enough information, but not too much information, to make sure that we have enough so that we can actually help you. So a clear description of an issue. We need to know the username, the account, the project, the allocation. I have a good example of an issue that happened actually this week. A user said, this is my name, this is my PI's name, and I can't get into the system while I could get on 2 hours ago. And so very quickly I responded, because different resources, you get onto the resources differently, is what resources are you using and how are you getting on the system? And then I quickly checked to see if you could get on the system. You get on the system. So then, since I wasn't provided a username, I looked for the first name and last name, check that out. And that person wasn't in our system. Not too concerned, because sometimes people use different first or last names over the years. They may change as well. So that wasn't too concerning, but then I went to the PI, and the PI also wasn't found in our system. So now I'm concerned that how is this person even accessing our system? And it kind of converted into a potential security issue. So providing the username right off the bat, the user was actually using a training account. So how they logged in was totally different than any other user who has a real account would be. So we could have resolved the issue much quicker. It took us about 3 hours of back and forth. The other thing is the account or the allocation that you're using. Many users have multiple allocations, so providing the specific one you're using is important. Job ID is really important. A lot of our questions do come about specific jobs. And with that job ID, we can sometimes get the list of nodes that it ran on the project, the start time, the end time, the resources that it's requesting. If it's actually running, we can also get the working directory and the location of the error and out files. However, if the job is completed and there was a problem with it, we don't have that information. So having that information will help us to have that, instead of going back and forth and asking you these questions. Another important thing is always create a new ticket for new issues. A lot of issues, if they get closed, the title is different than what the actual issue is, and we might not, it will take longer for us to read through the whole thing and try and figure out what the problem is at this time. The final thing is always be nice to the support desk. I think there's a phrase, you get more bears with honey than with vinegar. The user support team will always be supportive and help you out, but it makes everyone, it makes it easy. It makes a more pleasant experience for everyone if everyone's not accusatory, I guess. So this is kind of my last slide. I wanted to mention that there's a lot of common issues that we have. There's access and logging in, file systems associated with sharing and usage, checking out what usage you're actually using on the file system, job charging allocations. We have different presentations within the complex program that addresses a lot of this stuff. So the Slurm scheduler, the policies we have, and getting information about jobs, running interactively versus batch, application software, what software is available on the system, in which fashion can we make those that software available to you, and finally performance. And with that, I am done. For more questions, or does anyone have any questions at this point? If you have any specific questions, I strongly encourage you for your particular job. If it's coming to SDSC, you can send it to consult@SDSC. If it's a more access-wide question, send it to support@access.ci, and it'll make sure that it gets transitioned to where it needs to go. So, Scott.
Welcome. And first, I'd like to say thank you very much for coming today. I know security can be a topic that's dry, and it's extra work. And I think in some ways it's counterintuitive, because we always talk about how to make things work, and now it's like security, we're talking about how to break things. That's kind of weird. So thank you very much for coming and for your attention. So let's get started. What to expect from this presentation? That's a little bit more condensed, but let's talk about what it isn't. First of all, this isn't all you need to know and how-to guidance in 45 minutes or less. It would be a disservice to you, it would be a disservice to everybody else in the community to even pretend that we can do that. But what we can do is some generalizations here. So let's talk about security, and at a general level, let's talk about raising awareness, and then maybe some tools or techniques that you may be able to use. And also importantly, a mindset for security. So this is not, okay, how do I deal with it? What checkboxes, what things do I need to do in order to be secure? But rather, how can things go wrong? And then what can I do to prevent it from happening or to make it less of an issue? But first, coming up, we're going to talk about a person who just kind of had a bad day. Jay is a PI. He followed some advice on a forum. As Nicole mentioned, you might want to make sure where you get your information from, because sometimes you get bad information. And here's what happened to his lab. Something happened, and we'll find out in a bit. But first, let's talk about some security folklore. And this is things that I've just encountered and heard throughout my career. And we'll talk about potions first. So potions, these are the kind of things that you're just like, you use it and then nothing bad will happen. It's kind of like a one-size-fits-all product or a practice. And the other hallmark of it is, it's like, this is all you need to do in order to be secure. And by the way, if you happen to see something that says it won't impact your work and is guaranteed to stop 100% of the threats, you might want to walk away from that, because it's probably a scam. Great at taking your money, though. But for legitimate types of potions, let's talk about some examples. Once again, there's like, install legitimate security software. It's the best. You may have heard that from some of your colleagues. Or just run a firewall. It'll keep the hackers out. Or a VPN. If you use a VPN, it makes sure it sprinkles security dust on your laptop and everything's good. So not too good. So what's the problem with these? Well, it's different use cases. Every use case has its own security needs. You may be working with data that's encumbered and has some data use agreements. You may have a workflow that has a really high requirement for availability, such as you're collecting data from sensors in the environment or telescope. And if your pipeline is dead, well, you can't really rewind the universe to go and try again. And then different use cases have their own tolerance for disruptions. Going back to the interruptions, if you have security software and it's like, oh, we're going to shut the system down for an update. Well, what if you actually need the system up? Versus if it's tying up a machine instead of tying up the CPU instead of doing computation. So You're probably wondering, with all these variables, how can they even know that my use case is applicable? How do they know that it's not going to impact my work? They don't. And it's also noting that even though there are potions, and we've already poked holes in them, some of them are useful, but none of them are sufficient, and we will learn about one of those in a bit. The grain of sand's here chosen because it kind of represents the variability in the number of use cases that you may have in your research and education work. So let's talk a little bit more about invisibility cloaks, or what I like to call a switch over to a mentality rather than a thing or a process. So these are things that people will think about to argue that they really don't need to do anything. So inaction by arguing that they're not a potential victim. It's not going to happen to me. So a few examples is I don't need to do anything. I don't need to worry because my research is public. Or I don't have any sensitive data, so why would anyone want to attack me? Or I just have nothing to hide. I'm not worried about it. Or I'm just a random person. I don't stick out. What's the problem here? Well, there's a problem with this mentality, and that's the attackers, they don't really know that there's something interesting or there's nothing interesting in your account until they break in. So they got to break in and go, oh, well, that was a waste of time. And it also assumes that you know what the attacker's looking for. You think they're looking for your data, but actually they might be doing something else, like looking for another way to get onto a different machine or how to mine Bitcoins. And that, surprisingly, is something that happens a lot. And also, it neglects the fact that not all harm is caused by attacker. As Nicole alluded, there are other people on the machine and the environments, and sometimes they make mistakes. And of course, there's always technical issues, hardware failures. It happens. Completely on the opposite side of the spectrum, but still a mentality. There's no one's out to get me. We are now going to, everything's out to get me. And that's inaction because, you know, it's not sufficient. Nothing's going to work. Nothing's going to protect me, or it's overwhelming. So why even bother? And some examples, you know, it's going to happen to me. Like I said, why even bother? Or I don't have time for this. And someone actually told me the last one, and I wasn't really happy about that answer. So what's the problem with this potion, or sorry, this folklore, or this thought or mindset? It throws away the fact that you actually have quite a bit of control over the situation before it takes off and has a life of its own. You can make attacks more likely to fail, and you can also make the attacks that do succeed less successful or less impactful. Sorry. And the greater issue with that approach is that it promotes a false dichotomy. The notion that security and work, you have to choose between one or the two. And that's kind of pervasive in both the IT and security community. And it's just really bad because it just shuts down any productive dialogue in reaching a secure and useful environment. So what can we do then? Well, let's step back, take an approach to security that we can work in remaining couple of minutes, remaining 30 minutes or so. I've taken a slide here that is about crossing the street. You know, you cross the street, you're taught how to cross the street. You look both ways, you look for cars, and cars might not stop. What do you do if there's a surprise? You may jump out of the way or run out of the way. So it's the same way here with security. We'd be able to spot the danger, reduce the danger. Going back into the car analogy, you may want to judge the speed of the car and see if it's going to hit you, or if it's going to hit you, get out of the way, jump out of the way, run out of the way. Don't stand there and wait for something to happen. And then if all goes bad, have a contingency plan. So that's kind of the approach we want to take here. Be able to use your intuition to spot some problems, then reduce the chance of that problem happening or the impact. And then if all else fails, what are you going to do? Okay, so we all have some intuition in in areas that we have no expertise in. We not be experts in the field, but we're armed with some basic knowledge. For example, you don't need to be a structural engineer or materials engineer to note that standing on the top of a step stool is dangerous. You may think, hey, there's a problem here. Similarly, you don't need to be an electrical engineer to notice that there's something sketchy with this plug, and maybe you shouldn't plug it in. And then finally, on the third picture here, those are a bunch of oxygen tanks. And if I were in a room right now, I would ask everybody to raise their hand if they had an idea of what may be the problem with this. But since we're virtual, that's a little difficult to do. I'll just skip to the end there, and they are not restrained. So if one of those tanks happens to fall over and the valve on top breaks off, and the tank turns into a missile and can actually kill somebody, now you have a room full of those. Develop one. See, we're not all experts, but we're able to see areas that are like, see situations that are like, maybe there's a problem here. So let's talk about a case study. So as you may remember, the PIJ, who, by the way, that's not J, that's a person who doesn't exist. There is a site for that. J's researchers, they found their accounts at several institutions were just locked. And they were like, what's going on here? All the computers in the lab, they needed to be analyzed and cleaned up. And this took a while, almost 2 weeks. So as you might imagine, there wasn't a lot of work getting done during that. But there's more to the case. So there were multiple, as you heard, there were multiple institutions. Each of those institutions has security analysts, and they had to go and do analysis. And that was easily hundreds of person hours spent on this incident. But on the bright side, the data that was exposed and handled in the lab, it wasn't controlled or encumbered, so there was no notification. And as far as we know, nobody was injured as a result. So how does this happen? Or wait, not how does that happen? So a little bit of background. As a researcher in R&E, you may collect accounts at different sites like Pokemon. Each site has its own resources, and they are tuned towards doing one type of research or providing a type of a resource that another site may not have. For example, storage or GPUs or CPUs or large memory. So as a researcher, you may acquire accounts at different sites, and this is exactly what happened to Jay. And Jay had some issues, so he's got to log in from one environment to another and be able to do it quickly, and it's kind of hard if you have to type in passwords all over the place. So he thought, well, maybe I can script something, but he can script something and run a command, and then it'll type the password in for him. And he realized that, yeah, that needs a password, and he knew a password, putting it in a text file was a bad idea. So what's next? Well, his colleagues mentioned something about SSH keys and being able to use those instead of a password. And what we know about SSH keys, not a whole lot. So there's a little bit of background for those not familiar with SSH pub key authentication. You create a key that's composed of two pieces, a private key and a public key. You put the public key on the machines you want to log into. The private key stays on the machine you want to log into from. And once that's done, you should be able to just freely move between the machine with the private key to the ones with the public key. So back to Jay. Could be a little bit difficult to do this. So what does he do? Or what everyone else might do? Google it. And this is what he found. Some advice on the forum. You have to generate your key, and you're prompted to enter a passphrase. And the advice was it's optional. You don't have to do it. You might do it. You might not do it. It's okay. So passphrase, password. It sounds like something even harder. So Jay decided, let's not do that. Then he followed the instructions, rinse, wash, and repeat across all of the accounts, all the accounts on the different sites. So create 3 private keys in this case, distribute all of the public keys between the machines. And now we have this web of trust or mistrust that's just waiting for something bad to happen, and something bad did happen. An attacker got into one of those many accounts and then enumerated all of the places that were accessed from that machine or that account, and then tried using it because there was a private key there that had no passphrase on it. And they're able to get to some machines and some others, but that's okay. That one didn't work because they tried another machine and rinse, wash, and repeat, and then boom, everything is compromised. But that's not all. As you may have heard, the researchers in the lab also were affected. And that was because they did the same thing with all of their accounts, their own accounts, and then some of the individuals, they put their coworkers' public keys in their own accounts, so one person can log into another person's account, or vice versa. And you might be wondering, yeah, it might be a bad idea. And then there was one machine that had the public keys added to the root account. So this allowed the attacker, once they became one of the people in the lab, to log into this machine and then become everyone else. And guess what? There were a bunch of unprotected private keys sitting there. So this just spread out all over the place, and it was a big mess. And that is a pretty big mess over there. Order n squared. So talking about intuition, can we spot the danger here? Well, SSH keys, they let a client in possession of a private key log into the SSH server. So maybe that might be something to look at. And then we also know that some individuals, they logged in, they added their coworkers' public keys to their account. And maybe that might be a problem. So talking about the first one, well, what happens if someone gets a copy of the private key? Think about that intuition, follow that line of thought for a moment. So if they get a copy of the private key, then they can log into any machine that the public key is on. So isn't that kind of like a password? And isn't storing a password on disk dangerous? So isn't storing an unprotected private key on a machine dangerous? Maybe. And for the accounts, well, isn't this like giving the coworker their password? And that's probably against policy, right? So don't do it. So what can we do? We've identified it. Yeah, there could be a problem here. And what kind of tools do we have to reduce that danger? For SSH keys, you got to protect it. That's the bare minimum that you got to do, is protect your private SSH key. And the standard way of doing that is a long passphrase. Long passphrase, I mean like 26 characters, not 8. If you got 8, that's too short. And then if you can, try to minimize the number of copies of your private keys. Or minimize the number of copies and the number of private keys. Keep them on the machine that you want to touch, that you're touching, your laptop, and then use SSH agent to move between machines. You can forward your SSH agent, and you don't have to keep private keys on any of your other machines or other accounts. If we have time, I will be able to demo something called SK or FIDO2 hardware-bound SSH keys. These put the SSH key, the private key, in a thing that looks like this. And it's really hard to steal and abuse. As for the account sharing, just don't do it. Don't share your account. As CI operators or cyber infrastructure operators, we really don't like it when people share accounts, because when something goes wrong, now you have two people blaming each other, and then it turns into a mess. So if you have a problem with access, like you're trying to open a file or share, or a file that your colleague has made available or deposited on the machine, you're like, I can't get to this, I got permission denied, please reach out to our user support, and they will help you out with getting that access. There are things we can do to make that happen that do not grant you access to another person's account. I have another case study coming up. M is a senior staff member. She was working on a proposal, and she opened a document. Document says, you need to log in to edit this. Thank you very much, Office. And here's what happened to your account. And first, let's talk a little bit more about looking at for danger and building on that mindset and intuition, breaking down some things. So, critical component of security. It starts with two fundamental questions. What are we protecting, and what are we protecting it from? Wow, my slides are broken. Sorry about that. This is what happens when you use word slides on OpenOffice. So the question is, what are you protecting? What are you protecting it from? So for the context of, or for the purpose of this discussion, we're talking about two things: the cyber infrastructure, which is the thing that we operate, and your research, which is the thing that you're doing. And then at the intersection of the two, there's your account. Oh, thank you very much. The CI operators, it's us. We deal with most of the dangers that are specific to the cyber infrastructure or the environment. You don't have to worry too much about that. But what about your account and what about your research in your account? Well, we'll get to that in a second. Where do we start? Some people say let's start at the very beginning. I say let's start at the end. What is the end? Think dangerously and think about what's going to happen if something goes wrong. Not will it happen? You're going to get caught up in will it happen? It's not going to happen, so I don't have to think about it. No, don't do that. Let's forget about that. Let's just say it's going to happen. Now, what are you going to do? Imagine the danger. What if a danger manifests? And ask yourself, does it even matter? If it doesn't matter, well, don't worry about it. And if it does, well, how are you going to be affected? And who knows the consequence of that particular danger? That's going to be you. We don't know what you're doing. The only people that know how a danger is going to affect their research are the people who are doing the research and expect and are knowledgeable about how the code works and how the data is being used and how the data is sensitive to different types of danger. For example, some types of research, data corruption, minor data corruption isn't too big of a deal because it's noisy data to begin with. In other cases, a small data corruption can mean that somebody gets injured. So yeah, you're the best person to know. It's in your research, it's in your code. You know the code, you know the data, you know the research, you know what's supposed to go in and come out. So if we're in person right now, I would say, hey, who's got a credit card on them? Somebody will raise their hand and I'll say, hey, boom, your credit card's gone. What are you worried about? So collectively, those of you who are watching, think about that and answer that in your head and go, yeah, what would happen if my credit card disappeared? What would I be worried about? Think about that. So dangers to your account, that part is pretty straightforward. As a CI operator, we want to make sure that only you have access to your account. That's the prime directive. Don't give your account out to anyone else. Don't do something that's going to let someone else get access to your account. So the only danger you have to think, or the only thing you have to think about is this something that is going to give somebody else access to my account? The areas to think about or focus. Does it facilitate credential theft? So this is the thing where it's like your password or something else gets stored on a disk, sometimes without encryption. A hallmark of that is if you run a utility and it prompts you for like your login password, and then the next time you run it, it doesn't, and it just works. Does it contain or help install malware? This is one of those things where one of the things you can run into if you're running untrusted code, or you've got like a program from a forum attachment, or you found it on Google somewhere, posted on Usenet. If you're introducing sketchy modules from like NPM or Python, not all of them are sketchy, but some of them, especially if they're typoed, mistyped, the name is mistyped, and it still works, you might want to pay attention to that type of thing. And then you go to a forum and it says like cut and paste this command and run it and push enter. And another thing to think about is, does it let you bypass your CI login, your CI operator? That's us. Does it bypass the login process? You have to enter, for us, you have to enter in like a password and possibly two-factor, or have an SSH key, or log in through our portal. And is the thing that you're about to do, is it going to bypass that? So an example might be Jupyter Notebook or a Globus Connect Personal. So you run like a Globus Connect Personal instance on your machine, in your account, and then connect to it, and surprise, there's all your files. And VS Code is doing that too now. So you can set up open a connection to our login nodes using VS Code and edit your code there, and it'll bypass the login process. Is this a good idea? Maybe not. So what kind of tools do you have that you can use to help address some of these dangers? Multi-factor authentication, there's a place for it. If I didn't mention it, I would probably get beaten up as soon as I get off the phone, off this call. So it's helpful, especially if you have passwords only. And we have tools for common tasks. We maintain software packages and libraries, which you may have heard about or you will learn about. As an example, there are a few examples listed there. And also minimize your dependencies. So you're developing code, or if you're trying to modify somebody else's code, there's going to be libraries and packages and whatnot, or even programs that are required in order to run that pipeline. Please check if they're available in the CI first, in the cyber infrastructure environment first, because it might be there. And if it is, please use it. They're optimized to run in that environment. And for a bonus, they're less likely to contain malware. And then similarly, when you get your code, try to get it from a trustworthy source. Forum post, probably not a good idea. GitHub, maybe a good idea if the person posting it is reputable in the field for which they're distributing their software. And then once again, I need to remind you to avoid storing passwords and password equivalents, which includes unprotected private SSH keys on shared CI. So hundreds or thousands of users on a machine, why would you put a file on there that can let somebody else who reads that file log into all of your other accounts? Just please don't do it. Okay, so your research. We talked about your account. Let's talk about your research. That's a little bit harder to do because there are no hard and fast rules. Like I said, every use case is different. So how do we handle that? How can we handle that? Well, in security, we have a thing called a CIA triad. This is not the Central Intelligence Agency, but rather a reference to 3 priorities or areas of focus for security. And those are confidentiality, integrity, and availability. So if you think about your dangers to your research, what your research is sensitive to in terms of these 3 concepts and what things may impact them. Like I said, this requires knowledge about the use case, and that's going to be you. I'm sorry. I wish I could just be like, oh yeah, this, and this is all you need to worry about, but I can't. There's too much. There's too much that could be done. So as an example, let's see here. There's some areas of focus. What if someone else can view, change my data, my programs? I don't know, but think about that. In some cases, that might not be an issue. In some cases, it may be, but I can't tell you for sure if that's going to be your case. You have to make that call. Same thing about your data is corrupted, and how would you know if it was? That's something that worry about, and I think more people need to worry about is how would you know if your data is corrupted? You put it on the disk, that's great. Sometimes it gets changed in flight on the network, or the hardware is bad, and then the bits get flipped. And if you don't check your integrity before you process the data, you may end up in a situation where you're running suspicious or corrupted data. And if it is corrupted, what are you going to do? I have no answer, but hopefully after you think about that, you will have an answer. And then, and I have to bring this up about data and software. There's a thing called a DOA, or legal statute, or institutional policy. DOA stands for Data Use Agreement. So you may have a contract with a provider that says, well, we'll protect your data the following ways, and then in exchange, you'll give us a copy of the data. Is it affected by any of these things? If so, what does that say? Because if it says you need to do certain things to protect the data, then you need to do them. There's no thinking about that part. So some tools for general CIA challenges. For confidentiality, that's kind of the go-to. We do encryption. There's examples of some utilities for encryption. And don't forget about minimalization. If you have data that needs to be confidential and you can cut away some of that data, for example, you don't need to have social security numbers, you may need to have names, or you may have locations, but you don't want to give out exact geocoordinates. Get rid of it, strip it out. Minimalize the stuff that you don't need, because then, or cut out the things that you don't need, because then that's less things to get stolen. For integrity, the go-to there is cryptographic digests, also known as hashing or signing checksums. These are different than the ones that are inherently provided by the CI. For example, we do some of our file systems. They are backed by a thing that does this hashing on disk. So if the data is corrupted on disk, it'll get flagged as being corrupted. But plenty of things can happen between the disk and your application. So you might want to go and do some checksumming of your own. And then for availability, that's kind of just having the stuff available for the data or the resources available when they need to be. Those are the things we do: backups, redundant services, multiple copies. By the way, for SDSC resources, we don't do backups. Those are your responsibility. So before I head on over to the case study, I do want to go back and review and mention the CIA triad. So some examples of different priorities or workflows with different priorities. And take an example of capturing data from a telescope, like a radio telescope. You're streaming gigabytes of data per second into a file server. Confidentiality is probably not a big deal there, because I mean, it's public data, right? It's coming, you're seeing it coming, hitting the Earth from the universe. Integrity is probably important. You want to worry about that, but availability is probably the most important, because if that data is lost because the network's down or the file transfer is interrupted because the file servers were booting and installing patches, that's disastrous to the research. You can't rewind their universe and try again. On the flip side, you may have an application that is doing wildfire prediction. So given like sensors in the field and wind and aerial photos and satellite imagery, the pipeline predicts the location or the spread of a wildfire. And then the officials that are handling the response effort look at that map and decide where to deploy the firefighters. Well, integrity is kind of important there. So is availability. If the service is down, well, they can't make the decisions. But also the integrity is important, because if there's corruption in the code or corruption in the data, and the prediction goes awry and starts to indicate that the fire is going to spread somewhere that it actually doesn't, well, there might be people injured because the firefighters will get deployed somewhere where the fire is going to go away from. So different types of use cases, different types of priorities, and the only people that really are the best people that are in a position to decide what those priorities are you, fortunately or unfortunately. So let's talk about case study and go on fission. This is a story about M, and she just found out her account got locked. She logged in, did some editing on the document, and then boom, account's locked. She couldn't check her email, and because of all of this stuff, she couldn't work on her proposal. She lost 2 days because of the incident response, and then there was about a week's worth of cleanup. She had some personal information on the machine that she thought that, yeah, it might have been broken into, stuff like passwords for banking. So yeah, there was some time spent. So calling up, what did this look like? Well, it may have looked something like this. We didn't have like a GoPro or anything strapped to her head when she was doing her work, so I can't really say for sure. But based on her description of what the experience was like, it may have looked something like this. Open up an Office document or an Office, the online Office 365, and you got to log in. Well, for federated stuff or cloud stuff, that's not unusual. And so she logged in. She entered username and password, and then for UCSD, we do Duo. So it was a Duo to rescue. Well, maybe. She got prompted with a Duo push. Duo push said, "Are you trying to log in?" And she said, "Yeah, of course it's me. I'm trying to log in." Push approved. And then a few hours later, her account was locked. And that was a bit of a mystery to her, because an email was sent from campus saying, "Hey, your stuff got broken into. We're going to lock your account because of suspicious activity." But unfortunately, that mail went to the email account that she got locked out of. So they're just sitting there wandering around, and then finally gave us a call and said, "What's going on?" Yeah, got to do a push. So how could this happen? Once again, this is conjecture based on the experience. Based on how she described her experience and what sort of things are happening out there in the world and how the attacks work. So apologies, there is a icon that's supposed to be missing shortly under the word B with a question mark. There is a word icon that's missing. So what happened? What did we think that happened? Well, M went to go and edit this Word document that is the Word document had something in it that sent a login prompt, but the login prompt went, instead of to UCSD server, it went to an attacker server. The attacker server forwarded those that username and password over to UCSD server, saying, hey, you know what? I just want to go and add another authenticator to Duo. Here's my username and password. And then UCSD says, well, of course, that we can do that. But first, let's check with Duo to make sure that you are who you are, a second factor thing. So they check with Duo. Duo sent over a prompt, Duo push. M said, yeah, that's me trying to log in. So that information got pushed back, and UCSD's server said, yeah, okay, that's you. You got your username and password. Let's talk about adding your additional authenticator. And the attacker went and did that, and then took over their account. So how did this happen? How could this possibly happen with the with Word directing a login page, directing M to a login page that was under the control of the attacker? We're not exactly sure, but we suspect that there was a bug in Word or Office around that time, because there were a couple of them, and it may have been one of those that she got hit with. So what's the takeaway with this? Yeah, sometimes you can do everything right and still suffer. M did everything that she was trained to do. User, look at the screen. Is it somewhere that you expect? Yes, it is. Is it a legitimate login page from the information provided? Yes, it was a legitimate login page. She went and had her account set up for Duo two-factor, and Duo did what it's supposed to do. So she did everything right, but her account still got broken into. That's unfortunate. Should this happen to you, first thing is, don't blame yourself. You're a victim. Victims don't blame each other. The victims don't blame themselves. If you find yourself in that position, please report it to your IT personnel at your institution, particularly if you're using the resources, but also let us know. So if you've got accounts on CI at SDSC or any other site, please let them know that your account, your local account or your laptop or whatever got broken into. We talk to each other a little bit, but it's really nice to have a heads up and say, yeah, we know that these accounts got broken into, so we can start looking at them and then tie things down before they get out of hand. So what else? Nothing's bulletproof. Two-factor does help. Does help protect your account, protects other things that are affected by your account, but it's not bulletproof. Doesn't mean you shouldn't use it, but it means that there's a risk. There's a risk that something's going to go wrong, and hopefully you have a contingency plan. And sometimes the contingency plan is the only thing you can do is just scream. Sorry about that. So I got a little bit more time here. Shameless plugs. So I was talking a little bit about the FIDO2 stuff too. That may have helped protect this, may have helped address this case. If M had set up a FIDO2 authenticator with Duo, one of these things, she would have gotten a prompt that looks a little bit like this, where she would have the device in her machine and then push on the button and then log in. And what's so special about this? Well, it's a hardened hardware device, so it's designed to protect cryptographic secrets. You put the keys in, the keys don't come back out, and they're pretty cheap. $20-ish for the entry level model, and then they start to get really elaborate, like little tiny things that can live on the side of your laptop forever. Those are a little bit more pricey, but it's designed to prevent cloning, so you can't like take your key and then take all the stuff and make another key with it, and you can't read the contents of the key out and then make an emulator. It's very phishing resistant because the cryptographic exchange that happens with this, key goes through the browser, and the browser passes back the URL. So if you're being phished, where the attacker has somehow managed to direct your login over to a server that's not the right server, the URL is going to be wrong. The wrong URL goes into the key, and then the key goes, I don't know what the heck this is, and generates completely the wrong cryptographic response, and then the authentication doesn't succeed. So if Emma was using this, she probably would have not have had a problem with that. The attack would not have succeeded. She may have asked us, hey, what's going on with my login? It seems to be refusing, but I can still edit stuff. I'm a little confused. And then we would say, yeah, it looks like you're being attacked and your tools protected you. It also works with SSH, as I hinted. I'm not sure if I have time for a demo with that, but if we've got time, I can set up for a demo. And if you are working with SSH a lot, please consider getting one. You do need to have a near client and server, but at least I've been able to find solutions that work with both Linux as well as Mac and Windows. If you're thinking, well, do I need to buy this do I need to buy one of these just for accessing SDSC stuff? No, it also works with Google, Amazon, Google, GitHub, and a bunch of other services that are part of the FIDO consortium. So one key lets you log in, have secured login to those services as well as others. So with that, I'd like to say thank you very much for your time and attention. And we got a little bit of time for questions, and I can also go and set up to do some demos.